Right, good evening everyone. Welcome to our second session for our CCNA security short course. I hope you all enjoyed last week's lecture and you've had an opportunity to have a look at some of the resources that have been posted for this week. So there's a lot of resources up on the online site which talk about a number of different areas to do with access control lists. So now I'm not going to cover all of those in depth tonight. We're going to look at the basics of access control lists from a theory point of view, and then we'll look at, I'll take you through a couple of labs, a couple of simpler labs to give you an idea of the sort of things that you may be tested on should you want to go and do the official CCNA security exam some stage in the future, but also give you an idea of the sort of questions that you may also be asked in the multiple choice exam which we offer for this MOOC in week 6. So week 2 topics, ACLs, that's basically it. So a fairly in-depth look at them though. Okay, so firewalling with ACLs. Originally ACLs were, the first firewalls, the first mechanisms for providing firewalling. As we know now, there's a lot more complex methodologies and mechanisms that we use now with contemporary firewalls, but in the old days, before any of this has happened, I mean, there was no access control. It was just connection in, connection out, traffic passed through, and everyone was happy. And then there came the realisation that maybe there was potential for information to be stolen or hijacked or nefarious things otherwise happen. Excuse me. And so the requirement for ACLs came up, and they were, as I said, the basis of the first firewalls. Now, of course, they're used for many purposes, and there's a few of them there. So to authenticate incoming remote shell or remote copy sessions, to block unwanted traffic or users, to control access to your VTY lines, so your terminal lines, to identify or classify traffic for QoS features. So in other words, to this traffic is going to go in the priority queue, this traffic is going to be marked CS1, CS2, so on and so forth. Okay, so for working out how you're going to prioritise your traffic, how you're going to treat your traffic. To limit debug command output. So this is a really important one. So I'm not sure how many of you may have done debugging on a live router, but if you were to type the debug command, debug IP packet on a live router, you could potentially get a heck of a lot of guff scrolling up on your screen, which then makes your terminal session, or if you're connected to your console, potentially unusable. So we use access lists to control the limit of the traffic that can be shown through the debug command. So we can use access lists to also provide bandwidth control, not explicitly, but to match traffic on which we're going to control the bandwidth for. To provide NAT control as well, so we can specify what IP addresses we're going to NAT for, what IP addresses we're potentially not going to NAT for. Are we going to source NAT them? Are we going to destination NAT them? To help reduce the chances of denial of service attacks. To restrict the content of your routing table, so in other words, if we're using dynamic routing protocols between, say, yourself and a provider or yourself and a partner, there may be certain routing updates that you don't want to send. You don't want to tell them about certain networks that you're advertising internally. So you use your you use your access list to then apply to different mechanisms, which we're not going to go into too much in depth because this is security CCNA, not a networking CCNA or CCNP, which that probably fits into more. But you use your access list as a methodology for classifying the traffic that the routes that you don't want to propagate, or alternatively that you do want to propagate. And finally, on this list, to trigger dial on demand. So some of you may have worked with DSL services or perhaps ISDN in the old days, if you're an old fellow like me. And ACLs were used to specifically detect traffic that we thought was interesting, and therefore we wanted to send out over our dial-on-demand interface. So we don't want the interface up all the time sending traffic. We only want to send certain traffic out across that link. So we use our access control list to determine which of that traffic we need. Now I've just got a question here, a little bit random, so I might deal with that. It's just about SSH. I'll deal with that shortly. Okay, so I'll just push on from that. So access control lists, in terms of what we're going to be talking about with reference to the CCNA security, it's really only two things that we're really going to concentrate on, and that's to restrict traffic or to identify traffic in some other way. An access control list is an ordered set of rules. Okay? Each line in the access control list matches a set of criteria. And we're going to have a look at these more in detail in a moment. I just want to cover the theory and get that out of the way. So an ACL matches a set of criteria. Now each line within that access control list is called an access control entry, or an ACE. Okay? So they're sort of interchangeable terminology, but generally when you're talking about access control list, you're talking about a list of entries. When you're talking about access control entry, it's a single entry within the list. So when you're identifying, when you're restricting traffic, it's either permit or deny. When you're identifying traffic for some other purpose, such as QoS or adding into route maps or whatever, then the permit is please include this traffic, whereas a deny is exclude the traffic. Okay, so don't put it in or do put it in. The primary purpose we're going to focus on tonight is filtering traffic. Now there is a lot of resources that I've put up in a folder on the online portal that go into detail about a number of different types of access control lists, and we'll see those as we go along a little bit in the lab. In the couple of lab exercises I'm going to do, you'll see those. But I'd have a read through those. There's too much material to cover in a single MOOC session, and some of it is not specifically relevant to the exam, but there's little bits and pieces of it that will be. So I'll go through that in a second, shortly, what you need to know for the actual exam. So in terms of tonight though, primary purpose is to filter traffic. Secondary is to identify, and there's a couple of spots in the labs we'll see where we're going to identify, as I said before, defining interesting traffic to bring an interface up for the purposes of encryption, and we'll see that later on, I think in week 5. We're looking at VPN tunnels, and so we will be using, potentially, depending on the lab, we'll be using ACLs to identify which traffic we're going to actually encrypt across the point-to-point VPN tunnel. And also for policy routing, as I mentioned before. So we want to send traffic X down this pipe, traffic Y down another direction. Also identify routes to filter, allow, and routing updates, which we've talked about, and identifying traffic for quality of service mechanisms. So types and subtypes. Basically the standard IP access list will only allow you to filter on source address only, and we'll have a look at one of those in a second, an example of those. The extended access list will allow you to filter on source addresses, destination addresses, and other layer 4 information, ports and protocols, basically. Okay, so a little bit more, whole lot more flexible in what you can do with them, but again, it's a horses for courses type thing. You use the access list methodology that suits your requirements. Named access lists, they're not that dissimilar to the extended access list in syntax. However, instead of using a number to assign to the access list, we can give it a name, which then means it's maybe a little bit easier for you to read in a config, a little bit easier to match up with other parts. Because those of you who have read a Cisco router config will know that the access lists all go in one area, and you can read through them, and they can look a little bit confusing, and then you've got to try and match them up with the apply statements in other areas of the config. And again, we'll see that when we start our lab. You'll get an idea, A, how to configure them, and B, also how to read through the config and make sense of where access statements are and how they pertain to the actual restricting of traffic from one or the other. And time-based access lists, so-called lock and key. So this means this will allow certain traffic at certain times of the day, but not at other times of the day. Okay? And reflexive access lists. So these are basically allow transitive entries that react to session establishment. So as a session comes up, we'll say, all right, we'll allow that traffic. It creates a access list based on the traffic flow that we've said is okay, and so it dynamically creates that access list, and we'll have a look at that a little bit in the second lab as well. That'll start to make a little bit more sense. Okay, so what can we protect against? We can protect against many things. This is not an exhaustive list, and again there's some detail in your readings. So we've got IP address spoofing. So spoofing is the process, for those of you that are not sure. Spoofing is when addresses will start appearing on certain interfaces when they shouldn't be. They shouldn't be coming from that particular direction, or they shouldn't exist in that direction at all. So for example, you may see, for instance, if you think about RFC 1918 addressing space, for those of you that are aware of that, there's 3 different addressing spaces that are marked as private IP addresses only, so they're not routable on the internet. They're never routed on the internet. One of those address ranges is, say, for example, 192.168.1. something. So if you were to start seeing IP addresses for that range come in through an internet-connected interface, you would know automatically that something wasn't quite right. And that's, that's an example of where spoofing may be used. It's fake address purporting to be something that it's actually not. Okay, TCP SYN flood attacks. So basically what these are is a TCP connection has a three-way handshake at the beginning of it. So the first packet will send a synchronization packet into the destination. So if you're sending out the internet somewhere and you send off a web request, that web request will go off, it'll send a SYN packet to the end host. And I'm simplifying this greatly, but send a SYN packet off to the end host. And it will respond with what's called a SYN-ACK, which is a synchronized packet and an acknowledgement packet to say, yes, I got your first packet, here's my first packet. And then the next part of the session establishment is your machine sending back the final acknowledgement. So there's that, can I have some information? Or, it'll send up a request, hello, are you there? It says, yes, I'm there. Are you still there? Yes, I'm there. So you establish that connection. So the SYN flood is basically sending thousands or hundreds of thousands or more of these SYN packets into an end device with the purpose of trying to overwhelm the connection table. Okay, so that's something else that access lists can actually protect against. Reconnaissance attacks. So reconnaissance attacks are quite common. It's just basically people doing enumeration, trying to find out more about your network than what you want them to know. The general vulnerabilities, in some cases, yes, if we know there's certain vulnerabilities to certain protocol types, we can filter those with our access control list as well. But remember, access control lists are really a rudimentary or fundamental way of protection. They're part of an overall defense in depth, which we spoke about last week, and secure platform, but they're not going to stop everything. Okay, they're part of your security paradigm. They're certainly not the be-all and end-all. So they're simplified, and there's not a heck of what you can do for it. Now, just before I go through the revision example, I'll just answer some of these questions. So, I've got a random one. When configuring SSH, do you have to add the admin account to the local user database so you can still connect with it? I'm not sure exactly, but yes, you do need to have a local admin account on your device. It doesn't matter whether you're using SSH or Telnet, you'll need some sort of account authentication available to be able to log in anyway. So that's really independent from either SSH or Telnet. You can have local accounts, or you can use TACACS and Radius, as we talked a little bit about last week. If you have got TACACS and Radius, it's still recommended to have a local user account in any case, because if you don't and you lose your TACACS and Radius, then you're in trouble. Okay, extended or standard ACLs today, we'll be looking at both. To answer that question, would you use an ACL for failover? Probably not. There's other better ways to do your failover which don't specifically involve ACLs. So that's more to do with the complexities of your routing and monitoring certain interfaces to ensure that they're still up. And if they're not up, then you shoot your routing elsewhere. But you could use your ACL, for instance, to control, to do policy routing, but that's not necessarily based on your failover. Okay, that might be for certain reasons. So you might want to send a whole heap of traffic at your 5 meg connection on the internet because it's faster than the backup one you've got, which is only, say, 1 meg. And so you may use it in that circumstance, not specifically for failover. We are going to cover some configuration details. There's a couple of people asking about configuration details. Yeah, we'll be doing that shortly. And IPv6 in terms of the ACLs, we're not going to look at those specifically in the lecture tonight. There is a little bit of material which will be up on the online website for you to view regarding that. It's not a huge focus at the moment of the CCNA security exam, so we're not going to cover it in depth. We're trying to keep to the actual specifics that you're going to need. Okay, so that seems to answer all your questions at the moment. So if we have a look at this revision example here, this is a picture that's basically taken straight out of a CCNA security study guide, a Cisco study guide. And basically we want to talk about how we use the ACLs and why we use them in certain ways. So if you look at the router in the middle, so if I just grab my spotlighter, if we look at the router in the center, you can see that we've got 3 networks coming into it, 3 lots of servers, hosts, so we're assuming they're all different IP addresses, and you can see that anyone can access anything. If we don't put any access list on it, then anyone can come in from any direction and do whatever they please whenever they like. Now if you think of it in terms of an analogy of a nightclub, for instance, and the router is a nightclub, we have 3 doors into the nightclub, and we want to be able to control who comes in and out based on certain rules. So in this case, we're going to say on the gigabit 10 door or interface, we're going to apply the following rules. Now we're going to say anyone who's got a blue hat can't come in, anyone who's got a green hat cannot come in, but will permit all other hats and permit everyone else. Now notice on the bottom, number 5, deny everyone. It's an implicit rule, what's called an implicit rule, and what that basically means is on the end of every access list, there is a implicit deny everyone on the bottom. So you don't see that in your access list, so you can top up your access list with all the different entries in it, and on the bottom, never see it, but it's always there, deny any. Okay, now that doesn't seem like a big deal, because we'd say, all right, fair enough. We're happy to deny everyone, but it depends on what you're trying to achieve with your access list. Okay, sometimes it can give you some undesirable impacts, and we may have a look at there's an example in the lab, I think, where we actually see that happen. Now it's important the order. What we're getting at with this slide is not only the important the rules that you have in, but it's important the order that you have them in. So for instance, if we just said, all right, we've got these rules, but let's put them in a different order. Let's say we put the first one, permit all other hats. Okay, all other hats, all other hats. What does that mean? Okay, we haven't explicitly said anything about what hats to deny, so permit all other hats, if we put that up the top, is basically going to let everyone in. And then you get to the second line, it says, no, you should be denying blue hats or denying green hats. And so already you've lost control of your access list. So the point is to be very careful with how you put your access list together. By the same token, with this one here, if you only had entries 1, 2, and 3 and you didn't have entry 4, you would deny blue hats, great. You would deny green hats, great. Then you would permit all other hats. But then you may not let anyone else in, because then you've got your last line which just says deny everyone else. So if you haven't got a hat on, bad luck, you can't come in. But we know from the list that we have here, the rules that we have here, that that's what's required. Okay, so it's just a bit of a revision example to show you that for those of you, because again we're assuming that you have CCNA level knowledge, so it's a revision slide to show you, okay, be careful with your rules, remember there's a deny implicit on the end, and think about where you're going to apply these rules and in which direction, which we're going to have a look at shortly. Okay, just another question. Is it, and it's a good one, is it best practice to put deny IP any even though it's there implicitly? I'm not sure whether it's best practice. Personally, I would do it, particularly in a new environment, or if I was setting up an access list that was a little different, or in a new particular spot. And the reason I say is that is because if you're, if for some reason you're getting more, let's say for instance you've got an access list that's primarily allowing traffic and not denying it, and you see you're getting a heck of a lot of denies, you may want to then go and investigate, okay, what sort of traffic is it that's being denied? Okay, so what do I have to change about my access list to stop that happening? So it gives you a little bit of extra information that may or may not be useful depending on what you're trying to achieve with your access list and what results you're seeing. The other thing it allows you to do is to log any denied traffic with that implicit rule, so you get a feeling for what's actually happening. Okay, so it allows you to just find out what's going on with your access list and then perhaps add in extra rules which cater for everything that's happening. So I hope that makes sense. Okay, we'll just go back in order. Okay, so moving on. So our standard and extended are the two main ones that you're going to be working with on the exams. So standard, the numeric ranges are 1 to 99, and then the new expanded range of 1,300 to 1,999. And I'm not going to insult your intelligence by reading it out to you. You can see the numbers there. So extended is a different range. Can you name them? Yes, you can. You can have name standard list and name extended lists. Standard can only match on source IP. Extended can match on source, destination, and layer 4 info. Now, the interesting thing is, the next interesting thing is placement. Okay, so it's very important that you get the placement of your access list correct. Otherwise, you can either block or allow traffic that normally you wouldn't want to because of, errant placement. So with a standard access list, you are better to place it as close to the destination as possible. So remembering, we are only able to match on source IP only. Okay, so but we need to place it as close to the destination as possible. If you think of that from a next point. So yes, that's right. It's close to the destination as possible. With the extended access list, you can either put it close to destination or source, but generally it's better to put it closer to the source to prevent unnecessary traffic from exiting your network. Okay, so because remember, you can have a combination of source, destination, layer 4 info. So it's very specific. The rule is very specific about what you're going to either permit or deny. And if you place it too close to your destination, you can actually be permitting other traffic from further into your network go all the way through until it gets to the end. Okay, gets right to the end, and then all you're basically doing is wasting bandwidth across your network. So that'll answer that one. Okay, someone's asked for a mixture of standard, extended, and named ACLs in a config. We'll see that when we get to the lab. ASDM shows implied deny any in ACLs. I think it does through the GUI, through the ASDM Java applet. It does show the, you can turn them off as well so you can't see them, but it does show them. Is IP-NE implicit across all iOSs, including older versions? I couldn't answer that question to be 100% definitive. I haven't worked with every single version of iOS, although I do go back to about version 10. But my first reaction to that is no. I believe in some of the earlier versions it wasn't, and that caused issues, so they then changed that later on down the track. But don't quote me on that. As I said, my experience with them goes back a little way, but not all the way back to the start. Okay, so applying LTLs. When filtering, so we're not talking about matching traffic here, we're talking about filtering. Applying to interfaces. So remember that they're processed sequentially. So from top to bottom, so make sure you get your rules in the right order. If you don't, you can end up in all sorts of trouble. And there's that implicit deny at the bottom. The other thing to consider is your direction. So inbound and outbound are the only two directions. Now remembering you can only have one access list per protocol per direction at a time. Okay, so one IP inbound access list, one IP outbound access list at a time on an interface. So if you've got a busy router or lots of connections going here, there and everywhere, it can be quite a skill to be able to put that into an access list that goes each way and have it work properly. So inbound basically means checking traffic that flows into an interface before routing occurs. Outbound checks traffic that flows out of an interface after routing occurs. Okay, so it already knows where the traffic's going to go. Now I'm going to see whether I'm actually going to let that traffic out. Whereas inbound traffic, let's see whether I'm going to let it in and out first. No, okay, no routing happens. Yes, routing happens. This equally applies to virtual interfaces as well. Okay, so it doesn't matter whether it's a physical or a virtual interface, still the same deal. Doesn't make any difference. Once again, one ACL per interface, per protocol, per direction is permitted at a time. Okay, so just got a question. What is unnecessary traffic? Unnecessary traffic is traffic that I was talking about the extended access list, placing it close to your source. Unnecessary traffic in that context is if, let's say, you're going from router A to router C through router B. So you've got A, B, C, you've got two hops. And you decide that you don't want to let web traffic go from router A to router C. If you place that extended access list on router C, so closer to the destination, your web traffic will transit from A to B to C and then get blocked. Okay, so it has to go through, but it goes through router A and B before it even gets blocked. If, however, you place that access control list on router A instead, it's dropped at router A. It never goes across B, and it doesn't get to C in the first instance. So it doesn't transit right across the network, and that's what I mean. That is unnecessary traffic because you don't want it to go to router C, but you're letting it to get to router C before you block it. So don't do that. Block it at router A, and then you save that network resource. You're saving those resources across your network. Source-based good to be placed close to destination. What's the logic in that? It's merely just to stop it as close to the source as possible, and again for similar reasons. Okay, because you're blocking at the source. You don't know where it's going to go. You've got no idea what the destination is because you're only blocking it on the source. So you're going to say, all right, well, let's block it as close to the source as possible to stop it from going out on the network unnecessarily. Because it might get to the next hop or the next hop, and then it's, we don't want it to go that far. We don't want to get there. So block it off at the source, stops it from wasting your network. Benefit for selecting standard over extended. Extended is just more configurable, so it allows you to go on source and destination address and port number if you want to. So if you want to, you can write an extended access list that just blocks on source and then put any into your extended. You can do, absolutely you can do that. But the great flexibility with it is you can, at any stage, customize your source, destination address and port without any trouble at all, whereas you can't do that with a standard one. So there's not, I mean personally, there's probably not that many areas that you would use a standard access list, other than say for limiting management access to your actual Cisco devices. Okay, next question. I'll just answer a few more questions, so just hold them for a second. I'll answer a few more questions I really want to push on here. When you say source, does that mean the interface the traffic is coming from and destination the interface is coming from, heading for? No, it's the source IP address of the packet, of the actual packet that's coming through the network. It's actually the source IP address in that. So it's really got not that much to do, nothing to do with the interface per se. It's the source address of the originating host of that packet. ACL, yes, stands for Access Control List, example. Exactly. Similar example for a standard ACL, yes, we'll do some standard ACLs in a minute. Yeah, good question. Disadvantage in using extended all the time and not even considering extended all the time, not even considering standard. Only a little bit in terms of processing, because it takes the router obviously a little more to process through multiple options than it would through a single option. But having said that, in most cases you would probably use extended access lists, as I said, unless you are very specific about what, you know, if it was just like, okay, I don't want to allow access from anywhere on this source network, then fine, nice and simple, you could use that. So I don't think it's not a great trade-off. It's not a great pain in the backside, particularly nowadays with the hardware that's in routers now. They're pretty good at catering for all that. So there's not too much of a worry. But yeah, good question. I say, okay, so I'll push on just for next. ACL order. You need to carefully consider the order of your rules, which was sort of almost spoken about. Put your specific or frequently used rules right at the top of your ACL. Okay, and the reason that is because they then don't get down further into the ACL, so it's less processing time. Put your most popular ones up the top, the ones that are used all the time. They'll get hit first, and then off it goes. The packet will go, and it doesn't have to go down through the whole length of the access control list. You might only have 2 rules in it, 2 or 3 rules in it, in which case probably not going to make much of a difference. But if you have 50 or 60 lines in your ACL, then it can make a big difference to the time that it takes to actually transit. Remember that with your ACLs, new entries will always, with normal, standard, everyday ACLs. So there are ACLs that you can insert your entries into, but if we're just talking about the normal everyday ACL, entries will always append onto the bottom. The only thing that follows that is that implicit deny. So the implicit deny is always at the bottom, but any other entry will just add in the order that you put them in. So best practice is normally to use something like Notepad, and usually Notepad's the best way to go. I wouldn't use Word or other word processing packages, simply because they can insert other unseen characters that if you then paste them into your router configuration, you can have undesired results. So normally you'd use Notepad. It's a great friend of network engineers. So what you would do, the process for changing, and I might go through that in a minute actually, but basically the process for changing your IP access list is to remove the IP access list, delete it, so grab the configuration, copy the configuration in Notepad, remove it, make the changes, apply it back on again. Okay. What will happen if there is no statement in an ACL? That's a good question. What happens if there's no statement in an ACL or we apply an empty ACL to an interface? If you were to do that, there is still always the implicit deny there, so it would deny everything. Okay, we've already had a quick look at this, but 2 main categories of ACLs we want to have a look at. The numbered, which are broken into specific ranges based on protocol. Now we're only going to look at IP ones, so we're not going to worry about IPX and AppleTalk and yes, very good. I've just seen a comment, real men use Vi. Yes, very good. Like that. Okay, constantly mentioning processing time. Does a detailed ACL make that much difference in processing? Not particularly, no. I mean, we're talking about, milliseconds here. We're not talking about, well, probably even less. We're not talking about a lot. No, but it's still a consideration that that may come up at some stage, depending on router platform, how much memory you've got, how big your ACL is, how much traffic you're going through your router, all sorts of things. Another question, how would I know if a specific rule is frequently used? You would use the log option for that, and we'll have a look at that in the lab in a minute. Okay, so named access lists provide a bit more flexibility. You can use descriptive names. Individual lines can be removed. Okay, so you don't have to do the whole, as I said before, remove it, change everything, put it back on again. Okay, new entries still go to the bottom, and you can use them either in the standard named access list or extended named access list, so either numbered or named. Either way you want to do it, not really a big deal. The difference is obviously it can give you a name that you can look at, and you can use, yes, you can remove individual entries. Now, someone's just noticed very intuitively that there is no numbers between 200 and 1299. There actually are, but they are used for other protocols, so things like IPX and AppleTalk, which we're not going to look at as part of this course, mainly because they're not protocols that are particularly well deployed nowadays. So it's just IP at the moment. Okay, I'll just hold your questions for a second. Just let me get to the actual lab part, and then I'll answer all the relevant questions, and then we'll go through the labs. And you may have questions after that as well. So ACLs use wildcard masks to determine two things: which part of an address must match exactly to be included in as either being a permit or deny or as interesting traffic, and which part of an address can match any number, so it doesn't matter. Okay. So a wildcard mask is just the opposite of a subject mask, and for those of you that, well, you all should have some sort of CCNA knowledge. You should have already come across wildcard masks in your routing. So it looks like an inverse subnet mask. So in other words, 0.255.255.255 is the standard Class A wildcard mask. 0.0.255.255 is Class B, 0.0.0.255 Class C. So an example here, if we had 172.16.0.0 with a wildcard mask of 0.0.255.255, then that would match any address that begins with 172.16, but it doesn't care about the last two octets in the IP address. Okay, so it's a direct opposite to a normal subnet mask. Okay, golden rules for wildcard masks. If a bit is set to a 0 in a wildcard mask, then the corresponding bit in the address must be matched exactly. Okay, so if it's a 0, it must match exactly. Whereas if you remember in the subnet mask, it was the other way around, wasn't it? If you had a 1, it had to match exactly. If the bit is set to a 1 in a wildcard mask, the corresponding bit in the address can match any number. In other words, it's the we don't care condition. So you can see in binary, I've just taken the previous example and we've popped it into binary. So 172, let me just put my spotlight on. So that's 172 in binary, that's 16 in binary, 0 and 0. Our wildcard mask 0, 0, 255, 255. The resulting mask, remember, if we say 0, it matches that. So all we do is we just transpose everything where the wildcard mask is 0, we just transpose that down, so that becomes 172.16. Anything with a 1, we blank it out and just say, well, we don't care. Okay, so 172.16.0.0. Okay, the standard ACL syntax is thus: access list 1 to 99, plus, yes, you'll have noticed that there are additional numbers, but this is just using this as an example, so don't take this as rote learning. So access list 1 to 99, permit or deny, source address, wildcard mask, and the optional log keyword on the end. Okay, so that's your basic syntax for your standard ACL. So fairly straightforward. And again, we'll have a look at that as we go through our lab. The extended ACL, access list and then the number, or it could be the name if it's a named access list. Permit and deny, again, are we permitting, are we denying? Protocol, so now we actually have the protocol. So are we using IP, so all IP, are we using TCP, are we using UDP? Then the source address and the wildcard mask, or you can put in the keyword host and then an IP address, or you can just put in any. Okay, so the source address wildcard mask could be any of a host, a network, a range of hosts on a network, or you can put in any. Okay. Now, if you were to put in the access list entry and you put in, say 192.168.1.1, and then the wildcard mask of 0000, it will actually convert that and just say host 192.168.1.1. It's clever enough to do that itself, and we'll have a look at that maybe in a second. Next part, destination address, again with the wildcard mask. So again, the same thing applies to that as applies to subnet address, the source address. Okay, so you can have any a subnet or a host in there. Then there's an operator. which is like an equal to, greater than, less than, and we'll have a look at those quickly in a minute. And then the port number, so you can actually specify a port number. And then again the optional log keyword on the end, which will again log the actual rule being hit and give you a count of how many times that rule is being hit. And if you put log input, it will give you a detailed line in your log buffer. Alright, so extended ACL port operators. In the last example we used EQ to identify the telnet port. What happened to my example? Did I not put it in? I didn't put it in, I'm a silly bugger. Okay, we'll have a look at an example for a minute. But basically what I'm talking about there, so I've missed that out, apologies there. So what we're talking about is this operator here. Okay, so we've got our access list, our permit or deny, our protocol, say TCP, source address, destination address, and we're going to say equal to or whatever. There's a number of different operators and they are. So there's equal to, so it matches a specific port. So in that case you could say equals 22. So if the traffic coming through was equal to port 22, so TCP 22 is SSH, then if that matched that exactly, then that would be a match on that port. GT, greater than, means all ports greater than the port specified. So if you said 1024, then it would only match on ports, if you said GT 1024, it would only match on ports that were greater than 1024, so the ephemeral ports. LT, less than, opposite. Okay, so if you put less than LT 1024, then it would match on ports less than that, so the well-known ports, but not anything above that. Not equal to, well that's opposite of equal to, so you could put not equal to 22, it would match on anything that wasn't port 22. And then range, so that allows you to put in a specific range. Okay, so you might say range 16384 to 22384. So that'll block out or match, not necessarily block out, depending on what your rule says, but that will match on everything in there. Okay, some examples. Okay. Match ports greater than 50, access list 101 permit TCP, so it's permitting TCP from, and this is what I'm saying, so we've got any, so from any source to the host, so if we just get my spotlight again. So we already know a couple of things, a few things you need to know looking at this access list. One is 101, so we know automatically from the number that it's an extended access list. It's permitting, this entry is permitting TCP traffic from any source, remember source comes first, to the destination, a host address of 10.22.15.20 if it's greater than port 50. So that means it would match on port 51 and above, but nothing less than that. If you want to match ports less than 1024, you can see nearly everything's exactly the same except the end part here, we're just going less than 1024, so that then will match on the well-known ports. Match ports not equal to HTTPS. So in this case, if we want to match all ports except port 443, which we know is HTTPS, then we put NEQ 443. And then we want to match all ports between 21 and 80 inclusive. So range 21 to 80. ACL counts. If we add the keyword log onto the end of each ACL line, it keeps a count of the number of hits. You can go there, so it's just log keyword. If we include more detail, if we want more detail, we put the log input keyword. Okay, and what that does is that will include detailed information, including the source MAC and the interface on which the packet came into. Okay, so there are two options that you may use to either troubleshoot your ACLs if they first go in, or if you want to find out what's going out on your ACL and what's happening with it, then you can put both of those. Maybe start with a log, and then if something's a bit suspicious, put your log input on it. But in the normal course of operations, when you know that you've got your ACL all fine and everything's happy, you would just leave it the way it is, and you wouldn't need that log input in that log. Named ACLs, two advantages over numbered. One, you can use identifiable names, and you can remove individual lines. You can't insert them. Okay, you can just remove individual lines, so it makes it easy to take it out. So for instance, IP access list standard, deny telnet, deny 172.18.00, wildcard mask 00255, and there's an extra dot in there, so that dot should be in there. Permit any. Okay, so we're saying deny everything from 172.18, but allow everything else through. An extended name list, IP access list extended permit web, permit TCP 172, but there you go. Okay, so that's just an example of where you can use that named access list. So you notice it's a little bit different. So instead of putting the number in there, you've just got a name. Okay, there's two sections. Okay, some lab examples. Now we're going to have a look at some packet tracer labs, but before we do that, I'll just scroll back up and answer a few questions, because there seems to be quite a lot. Going through security levels of the firewall interfaces. No, we're not doing that tonight. That will be next week. Next week's on firewall specifically. Is there an easy way to remove all ACLs before applying changes? Copy the notepad with a non-statement before each line, then apply the new lines. Brad, you've probably hit it right on the head there. The key, and I'll actually go through an example in a minute, which will make more sense. But that is basically correct. If you want to edit your access control list, you would normally take the configuration off, put a no in front of all the statements, and then paste it back on again if you were trying to take out certain statements. If you want to get rid of the whole access list, though, it's just simply a no access list number name gone. Okay, so it depends on what you're trying to achieve, whether you're trying to get rid of specific entries or the whole lot. Okay, that one's all right. Remove the access list from making changes. It's better than making, I would advise that you remove the access list before you make changes to it, because it's a whole lot better than making changes when it's still applied and suddenly find yourself losing access. It's always better to do that, in my opinion. I mean, it may vary depending on who you're talking to, but in my experience and in my opinion, I think it's better for you to remove the access list first, make your changes, and then apply it again. But I mean, that doesn't have to be a long-winded thing, and I'll show you an example of that in a minute, what I mean by that, how you can do it quite quickly without exposing your network to too much unpoliced traffic. Yes, you can. There's a question about annotating or adding remarks to access lists. You can use the remark keyword. So you can definitely do that. So you can split your ACLs into sections and then put just a remark above it, and it'll tell you what that particular section's for. So that adds to your readability. Very good practice to do. Okay. Yeah, that's true. I've just got someone made a comment about multiple ACLs and the latency of the network is bigger, assuming the processing time of many ACLs. Yes, you're right, but you'd have to, as you said, 100 ACLs. You've got to have a lot of ACLs for that, particularly with modern routers. Okay. Another question about CIDR. No, we're not looking at CIDR specifically tonight. That's more in the CCNA networking realm. Log syntax at the end of the ACL done. That's all right, Luke. I've already gone through that one, so hopefully that's answered your question already. There's a quick question about GNS. Yeah, you can use switching on GNS, the latest versions of GNS, so grab that. Can you have multiple operators? No, you cannot. So you can't put minus, not equal and range at the same time. So no, it gets a little bit tricky. Minimum iOS version feature set to use the lab at home. No, look, if you stick for something in the 12 range, I wouldn't go any earlier than that, but if you go for something in the 12 range, then you're pretty much okay, particularly for basic CCNA security and CCNA level stuff. Yes, adding the log command at the end of your ACL entry is optional. You don't have to put it there. And just another question about can the equal command define multiple ports on the one line? No, you have to use separate lines. Okay, so let me just, now that we've got those questions away, and good questions, guys. I'm glad you're asking plenty of questions, and I hope you're satisfied with my answers. Let me just start up, just bear with me for a second while I start up my copy of Packet Tracer, and I'll show you that, and we'll have a little bit of a look at it. Which one are we looking at? Oh, that's a bit silly. I mean, it looks like I've already got it open. Here's one I prepared earlier. Hey, there it is. Okay, so hopefully that should come up for you. I'll just check that you've got that coming up on your screens. And yep, okay, you've got that now. Now, if you've got any questions while I'm going through the lab, feel free to shout out. I might not answer them straight away, but we'll just have a look at it. Okay, so before I actually get into, so this particular Packet Tracer lab is about configuring IP ACLs to mitigate some sort of attack, and they give a specific scenario, so we'll actually go through that specifically. But just before I start that, let's get on to old mate router 1, and if we just have a look at the COI. Now this is going to be tricky because I don't know that you can actually see that, so I'll have to switch focus to here. Okay, why don't we just give that? Let's just have a look at this. This should give you a view of everything I'm doing here without having to worry about particular screens. So just bear with me for a second, guys. Sorry, I just want to make sure that what you're seeing is what I think you're seeing. And that's looking good. Okay, so here we have our router 1, and I'll just blow that up a bit so you can hopefully see that okay. Okay, so password. Okay, so my router 1 configuration. If I have a look at my run now by using the show run command, hopefully you can see this reasonably well. Okay, we have just a basic vanilla flavored configuration. So it's got some passwords on it. It's got the fast Ethernet interface with 192.168.1.1 IP address on it. It's got the serial interface 10.1.1.1, and that's pretty much it. And a little bit of routing. So I've got a static route. So as you can see from the network diagram there, we're looking at this router here. So I'll just put my spotlight on. We're looking at this particular router here. So it's taking traffic from the 192.168.1 network, which is this side, and routing it out across its serial interface to router 2, bus to router 3, and so on and so forth. Okay, so it's a pretty straightforward little setup. But what I want to show you here is just an example, and this access list isn't necessarily going to it's not going to necessarily achieve anything with this specific lab, because I'm going to go through the lab in a minute. But just as an example, if I make up an example ACL, let's say we want to on our VT wireline, we want to limit access to certain hosts. So say 192.168.3.1. So we would access this for a start, and remember, you can always use a question mark. Okay, for those of you that may not have that much access to Cisco equipment, you can use the question mark. It will basically tell you what you need to put in. So in this example, we're just going to block access to 192.168.3.1. So I'm going to use a standard access list. Okay, so we're just going to use number 1. And we hit question mark again. Next one is now, here's answer the question before. So you've got the remark keyword there. So if I want to, I can put in here remark. And then after that I can say limit access to VT wirelines for 192.168.3.1. Okay, there's my remark. Okay, now I've just had a question. Just had a question about making the text a little bigger. I don't believe that I can. Don't think we can Just let me try something. Apologies, we have a limitation there. Let me have a look at that for next week. You might just have to go with it at the moment. We can probably sort of look at preferences. Let's have a look. Don't believe that we can, but I could be wrong. So I'll just have a quick look while you guys are. There we go. I lie. Very good. So let's make it say, we're not 8 now, let's make it 16. And see how that goes. Oh, no. There we go, guys. How's that? That should be a whole lot better. Okay, so access list 1, remark, limit access to VTY lines for 192.168.3.1. So all that is remark. So we can access list 1, and now we're going to deny, and you can say, as it says, you can address to match any source host or host a single address. In this case, I want to put 192.168.3.1. Now watch what happens when I do this. So I put in my wildcard mask, okay? So I'm saying I don't want all of the numbers in this IP address have to match. That's what that's saying. Okay, now if we go question mark again, we've got no other option, so we hit enter. Okay, so now all I've done is I've done my access list, I've put a remark on it, and I've denied access to 192.168.3.1. If I just whip out again, and I have a look at my command show access lists, you'll see that standard IP access list 1, it's just put in deny host. Okay, so the iOS is clever enough that it will just put in deny host if you put in a wildcard mask that matches that IP address exactly. Okay. Now let's just put in another couple of entries. Let's say we're going to deny 192.168.2.0 0.0.0.0.255. Oh, 255. Humble fingers. Access list 1. Permit any, so we're saying anything else is, oh, sorry. Permit any, okay. So we know anything. Now in this case, the implicit deny at the end is irrelevant, because with this entry here we're saying allow anything else. Okay, so if we now go back and we go show access lists, you can see we've got the host entry, we've got the network entry, and we've got the permit any on the end. Okay, so pretty basic, that's it. Now, if I want to then, okay, let's have a look at it in the run as well. Okay, so if we have a look at it in the run, usually down towards the bottom, and there it is. Okay, when we have a look, you notice when we do the show access list, we only see the actual entries. When we do the show run, we see the remark as well. So in this case, if I wanted to edit that access list, I would do the following. Okay, so I'd run Notepad. Oh, Notepad's on the wrong page, so we're going over here. My wrong monitor. Okay, so I've got my Notepad. What I would do is I would go back to my running config. I would copy that off my running config. I'd pop it into Notepad. Thus, I would make whatever changes I wanted to do to it. So let's say we're going to say permit 192.168.3.1 now. We're going to permit 192.168.2.0, and we're going to deny 2.168.4.0.000.2. Well, let's do something else. Let's do 255.255 on the end. Okay, and then we put our permit any on the end. Then what I'd do is I'd go back to here, and just to be safe, you don't have to do this. You don't have to do this, but I like to do it this way because you know it's always clean. Okay, it's always clean. So you would go no access list 1. You would delete it completely. You then copy it, and you go paste. And there you go, you've got your access list back. So you can see, and I did that pretty slowly, really. So you can see there that it only takes 15 seconds to do a simple access list. Obviously, if you've got really complex ones, then first of all, the first thing I'd say is actually test them out in the lab anyway. But if you're going to plot, you can still do it. You can still do it quite easily. But again, it depends. It's going to depend on your environment, how complex it is, and how many access lists you've got, interfaces, traffic flow. What are they doing? Are they identifying? When you change your access list like you have to reapply.
Matt, your audio is breaking up pretty significantly.
Okay, guys, I've just been told my audio is breaking up pretty badly, so how's that? Is that better?
It's better. Yep. Now it seems to be okay.
Yeah. Okay. Okay. I have had some rather significant issues with my internet service of recent times, so hopefully we're not hitting one of those times. Okay. So the question was, when you change your access list, do you have to reapply it to the interface again? No, you don't. Okay. So if you have a access list that, now remembering, of course, that's a very good question because it brings up another point. I was using this one as an example with the VTY lines, but it is a very good point. Let's say, for instance, let's get rid of that access list, and we call it, and we say access list, okay, 10, and we go permit any. Okay. So just a simple access list. Now this access list here allows all traffic. Okay, we're all in agreement with that. But remember, there's that explicit deny at the bottom. So if I now go and apply this interface, this access list to my interface, so I go access, what am I doing? IP. So I'm using all the question marks so you can see. So IP access group 10. Okay, so let's say we apply it in the inbound direction. Okay, done. So now we've got that IP access list applied to our interface in the inbound direction. So if I go show the access list, we can see now there it is. The other another decent command you need to know is show IP protocols. Oh, not IP protocols. What am I doing? IP int FA01. Ah, it's interesting I haven't brought the interface up because we're at the start of the lab. Isn't that funny? Okay. All right. We'll cover that in a minute. The point I wanted to make about this is if now that the access list is actually applied to that interface, if I'm now going to change it like I was then, like I did before, so if I go show run and I have a look at my access list, so it's pretty simple, and I copy that and I take it over here. Now again, remember this is a very simplified example, so you may actually have access lists with many different entries in it, but it's still, the same theory still holds. So if I want to then add a line to that, 10 permit, so let's say we're going to change that, and we're going to say permit 192.168.2.1. See, I'm getting caught with my own wildcard masks. Yeah, so that'll end up converting into a host. And we're going to say 192.168.3.0 like that. So that's my access list. That's what I want to apply. So I'm going to grab that. I'm going to copy that here. And I go into my configuration and I go no access list 10. As soon as I hit that, bang, that access list is now gone. Okay, there's no access list. So, but if we do it, let's have a look at the run. Look at the run there. It still exists there. Okay, so the basic idea there is that if it's trying to apply an access list that's not there, not in all versions, but in some versions that will actually remove, you're gone. Access is gone completely. So you have to be, so even if I go paste, and then when I go paste, okay, access list is back, everything's back good again. So that's fine. So it's a very good question. So in full, what you would normally do is this. So we want to change our access list. You would jot out these commands. Okay. No access group 10 in. Exit. No access list 10 to get rid of the access list. So this takes the access list off the interface. This gets rid of the access list. This puts in your new access list. And we go back and we say access group 10 in. Now look, there's always ways and means of doing this automatically, and that, you know, in some versions of iOS it's not so much of an issue anymore. It's a good practice to get into though. You need to be sure that you're not cutting off access or doing things that you don't want. You're not coming up with undesirable actions. Okay, so in this case we just paste it back on, and you can see it just goes, no, whoop, I put something on the end of that. I've been a bit, oh, it's because I didn't do an accent. See, so there you go. When mistakes like that happen, and you mess something up like that, then you're back to square one again, okay? So you've got to be really careful. It's a perfect example. I did that just to make sure you are concentrating. No, I didn't. I forgot to do it. So we exit there. Oh, look at that. Yep. So that should have IP access group in. That's my mistake. Okay, so again, doesn't matter how many thousands of times you do it, you can still mess it up. Perfect way to start. Okay, so let's, what am I doing? Okay, so let's have a look at that again. Bingo. Okay, that's the way it works. So you can do it that way. So now let's just, okay, I'm mindful of time here, guys. Okay, I'll just have to answer some of the questions because I'd really like to get through this lab if I can. So let me scroll a bit. Yeah, I will put the packet tracer labs up onto Moodle. If you have a copy of packet tracer, then you'll need packet tracer 6.0 or higher to be able to use it. So it is available through the Network Academy or a net space login, but I cannot provide you with the packet tracer software. I can the labs, no worries at all. New iOS allow us to configure actual subnet masks instead of wildcard masks. Not that I'm aware of. No, it's still all wildcard masks. There's a question about the access list. If you've got many lines, can you edit it without deleting and reconfiguring? You can edit it. I mean, you can add entries to the bottom of it. If you want to take something out in the middle of it, though, no. You can add entries into certain spaces, so you can leave space in your access list using sequence numbers. So you can put a sequence number 10, 20, 30, or whatever, and that again is covered in detail in some of the documentation that's up on the website. You can add individual entries in, but it's very problematic in pulling entries out. In other words, you can't basically do it. So you need to be able to use your notepad or find some other way to do it safely. Yes, so another question just about numbering the access list entries. You can, with named access lists, you can put in sequence numbers. So that allows you to put in, say, sequence number 10 for one entry, sequence number 20, and then when you want to insert other entries, you can simply specify an entry sequence number that fits in between the existing sequence numbers, and it'll pop that entry in wherever you like. But at the same time, you can't pull them out. Okay. Right, so if let's just reload our router here. So I'm just mindful of time, guys. We're getting close, and I really want to go through this lab to give you a bit more of an example. So basically the idea with this lab is we want to, and I'll just get rid of my notepad for a second, pop that over there. With this particular scenario, we want access to routers 1, 2 and 3, but only from PCC, which is this computer over here. Okay, so we want access to 1, 2 and 3 management, but only through PCC. PCC is also used for the connectivity testing through to PCA, or in this case actually server, the server over here, using DNS, SMTP, FTP and HTTPS services. Okay, so there's a number of things we're going to do. Standard operating procedure is to apply the ACLs on edge routers, okay, which in this case is router 1 and router 3, to mitigate the common threats based on source and or destination IP address. So what we're going to do here is we're going to create ACLs on edge routers R1 and R3 to achieve our goals of only allowing management access to PCC and connectivity from PCC through to PCA. So the first thing we want to do is check that all our routing and everything's working in the first place. So if we jump on the PCC, and we go to our desktop, and we go to command prompt, we're going to see if we can ping, and where is mine? Hang on a sec, I'll just get my IP addresses up there so I don't have to keep referring back from my notes. So from a PCC we're going to try and ping PCA, which is 192.168.1.3. Okay, so we have a problem, Houston. We have a problem right from the start. So, oh, there you go. We haven't got a problem. How's that? So what, here's a question for you. Let's see if we can get an answer for it. Why would that have happened? Okay, why would it have taken a little while for the ping to respond? Okay, and very good. We've got an answer already, which is correct. I'll give you a little bit more time. And another one. Nope. Yep. Beautiful. Okay, so you can stop now, guys. Very good. You're all getting across it. So basically ARP. Yeah, so it's an ARP request. It takes a little while for it to get out. Okay, so we know that we've got connectivity coming up. So the first thing we want to do is to secure access to the router. So we need to configure an access list. We're going to use access list 10 to block all remote access to the routers except from PCC. So two things we need to do. First of all, we need to come up with an ACL that is going to do the job. The second one is to apply it to the correct interfaces. So, okay, assuming, so remembering, let's have a look at PCC. Let's put some details up here, and I'll get you guys to actually step me through it. I'll get you guys to help out with it. What are we doing here? Config. Okay, so our IP address on PCC is 192.168.3.3. Okay, so who can tell me, or does anyone want to have a go at just in the questions box, just see if you can come up with writing a standard access list entry that will only allow access from 192.168.3.3. Okay, so use the access list, use it as number 10, and I'll give you a minute or so just if anyone wants to have a go at that. And then we'll talk about where that's actually applied. So in this case, in this particular case, we're going to do it on router 2 and router 3. Actually, we're going to do it on all of them. So it'll be the same, basically the same access list. So we've got, we have got a winner. So the first one up with it was Noel. So well done, Noel. Your spot on the knocker. Now, there's a couple of ways. So if we were to go to, let's go to router 1, Cisco, blah, 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 blah. Okay, fine, okay. Let's just pop that one up there. And we've got router 2, CLI, and I'll just log into all of them so we're ready to go. Cisco 55. Normally I wouldn't be saying my enable password and console password as I'm actually logging into a router, but it doesn't matter in this case. Okay, so I've got all my routers up. Now, the winning entry from Noel was access list 10 in this case, permit host, or, well, there's two ways you can do it. You can either put in 192.168.1.3, 0.0.0.0, whoop, can't see that, on there. You can either put that in, and that will work, or you can put in the host keyword 192.168.1.3. Okay, so that now creates our access list. Now we want to do this on all our routers, so I'm just going to be a bit of a cheat here, and I'm going to paste that into our routers. And number 2 is the one we're missing. I'm going to paste that in. Okay, good. So that's one thing. That's the actual access list out of the way. The next important question is, how do I actually apply that to the router configuration so that it it only allows access from that IP address to my terminal lines? Okay, so terminal lines. So where do I put it? So give me some suggestions on where you think I should put it. So if you look at, if we just go back to our topology diagram here, and you can see the 3 routers. Is it a physical interface? Is it a logical interface? Where do you think I should apply it? Okay, so we've got quite a few people that have answered back straight away, and that's you're absolutely right. So it's on the VTY lines, okay, so the virtual terminal lines. So can anyone tell me what the command is to actually apply it? There was a question, should I include the deny any at the end? I don't have to, it's implicit, and for the purposes of the lab I'm not going to bother about it, but you could do it if you wanted to. Just a question from David about why access list 10. The reason, you'll see that when you get, I'll put the packet tracer lab up on Moodle so you can look at it. They just specify 10 in the actual lab itself, so it's just arbitrary. Okay, so line root. Okay, so we've got a few answers, right? So it's access. What is it? Access class. That's right, guys. Access class, and then we say 10, and we give it a in. Okay, because it's inbound connections. So access class 10 in. So if we go and do that on our other, so line VTY04, access class 10 in, and we'll do it on our other routers, router 3, line VTY04, access class, oh, forget, can't spell, 10 in. Okay, so that's great. So now we've restricted our access to our telnet line. So the next part of the lab is, what is the next one? Okay. Well, actually, first of all, what we want to do, that's a very good point, is we want to test whether it actually works. So if we go to desktop, and we generate, on desktop. Okay, so from here, what we want to do is, or is that the next one I'm looking at? Oh, there we go. Should be successful. Okay, so if we're to go to here, and we do our traffic generator, okay, so what we're going to do is we're going to generate some SSH traffic. Okay, and we're going to go to our router. So let's pick a router. Which router are we going to go to, guys? Let's say we go to router, so we go to router 2, so that's the one in the middle. So we're going to go to 10.1.1.2. Try and get to that. And we're going to send. Oh, what have I done there? Oh, valid source port. Silly me. Okay, so we're going to pick a valid source port, Cisco ephemeral, and we send dot. Okay, so we let that generate some traffic. We'll send another single guide, so fast internet. That's okay. Okay, so we send it a few times. Okay, we go back to PCC. Yep. Where is the concept? There it is. Mine's back. Source IP address 192.168.3. Single shot, periodic 10. Okay, so let's just send that traffic on. How's it going? Okay, so we're looking at this one here. Now, if we did check that, this is just going back to what I was saying before. We were talking about debugging. If we had to debug IP packet, let's see what happens here. I'll put the wrong IP address into that. Oh, I have to. I'm a silly bugger. Okay, so you can see now that I've actually got the source packet. Okay, you can see what debug IP packet does. Now you think of this. This is only sending SSH. Okay, it's only sending SSH every now and then. Imagine what this would be doing on a live production array with lots of traffic. So this is another example where we can, so we just do on debug all. So if we were to do, say, oh, it's pointless doing that, really, it's the same sort of thing. So let's just, the other way we can do it is if we jump over here and we do our traffic generation, 2. Periodic, let's go every 5 seconds with this one, and we'll send that off. I just want to demonstrate what this can do, why you would use this. Okay, so you can see there's a number of SSH packets coming in through there. So there's ones coming in from 1.3. What's going on here? Feeling that right. Ah, now that's interesting, isn't it? Okay. Can you see, everyone see the mistake I've made there? That's very interesting. If we have a look at this here, which creates another set of problems all on its own. 3.3. Oh, this is excellent. I love it when I make mistakes. It's showing directly how things go. Now you'll see that, notice how we've now got SSH coming in from 1.3 and 3.3. What I've done before is with the PC, I'd put the source address as 1.3 instead of 3.3. It was actually 3.3. And so what was happening then is you'll see there was some route failures, some RIB failures, and that was because I was sending packets from the 3 network, the 192.168.3 network, of the 192.168.1. So yes, problem on my behalf. Okay, so you can see it can fill up the screen. So let's do a debug okay, and have a look at it. If we go debug IP packet, as we were, oh, there, it doesn't support it. Wow, that's just wonderful, isn't it? What you should be able to do is go debug IP packet, and then on the end of it, place the number 10. So be able to apply an access list to it, but obviously Packet Tracer doesn't allow you to do that. So the example I was going to show there was that you could actually limit your output of your debug IP packet using an access list. Packet Tracer doesn't support that. So that's messed up demonstration up. That was rather rude of it, wasn't it? So all that effort for nothing. All right. But the point of that is that you can actually, if need be, you can actually limit the output of your debug IP packet, or any debug command for that matter, using an access list. Okay, which can be useful if you're in an area which has got a heck of a lot of traffic coming through it. All right, so let's go on and do the next part of this lab. So the other thing is we want to configure, and this is in the lab, we need to configure an ACL 100, so this is an extended IP access list, that will block traffic sourced from my own internal address space if it is not an RFC 988 address, so in other words 192.168. whatever address, and we need to apply it to our serial interfaces on our router 2. So the purpose of that is basically what we're talking about here is spoofing. Okay, so if I have a look at my that one. Okay, so the idea of this, so we're access list 100. Now I won't get you to go through this one too much because this is a bit long-winded, this one. But if we have a look at what that is in terms of a notepad, just let me type this up. Okay, so what we've got here is this. So let's just pump the font up a bit for you. So you can see what I'm doing. Okay, so there's our access list 10, so we're not going to worry about that anymore. Access list 100. We want to deny any RFC 1918 addresses. So RFC 1918, for those of you that aren't aware, are addresses which are reserved for particular use, for special use. So the 10 address class 172.16 to 172.31 and the 192.168 address are used for private IP addressing within IP networks. The 127, anything starting with the 127 is a loopback, and the 224 are experimental addresses. So we want to create an an access list that prevents any of those from crossing our network. So in this case, there's our access list. That's actually what it is. So I will paste that into our configuration. So we want to put it on router 3. Just go back to exit and we'll paste that. Okay, paste it on. Now, have a think about where we want to actually apply that. Okay, so we want to stop it. It's access list 100, so it's an extended access list. So think about where you think that should actually be applied. Because remembering with the extended access lists, remember where we actually place them. So think about where we actually place them. Okay, so we've got answers. Let's have a look. Oh, my question box gone. Okay, good. Right, so where we want to apply this, so if we read the statement, we're going to block traffic source from your own internal address space if it is not RFC 9N18. Where would we apply it? The answer is we need to apply it onto the serial interfaces. Okay, so if we go show IP int brief, and see we've got our serial 001 in this case. Okay, so anyone tell me what the command is? Have a guess at what the command is to actually add that? Better make my question box a bit bigger. Okay, so in this case, we want to stop, what we're trying to do is stop that traffic from coming into our network. So that's actually going to be applied in the inbound direction. So what we're trying to do is stop this traffic from coming in from the outside. So it would be IP access group 100, whoop, in. So that's going to stop any of that private IP addressing from coming inside. Okay. And the last step of the equation is to deny all outbound packets with a source address outside the range of internal IP addresses. Okay, so this is a bit of a trick one. It's actually, so what we're trying to do here is, if we look at router 3 here, is we're trying to stop, so if we look at the IP address over here, so here's 192.168.3, so if we assume there's other hosts on this side as PCC, we want to stop anything other than packets from that network traversing this link. So have a go at what you think the access list for that might be. It's a pretty simple one, where I use an extended, so use an extended with a number of 110, so it'll be access list 110. And then, so I want you to tell me what the command is, what the access list statement is, and on which interface and in which direction. So it's got to stop basically anything other than traffic from this network getting out across this router here. Okay, now let's have a go. Okay. So in this case, conft, yes, we have a winner. I think that looks good. Okay, let's have a look at what we've got. So correct answer is access list 110 permit IP source address, so 192.168.3.0, 0000225, and then any. Okay, so that's your access list. Now, the next question is on which interface and which direction should it be applied, do we think? So again, we want to stop that traffic from transiting our network. Being an extended access list, though, we want to try and get it as close as we can. Normally you try to get it as close to the source so you don't stop this, so that traffic doesn't go off. So we've got an answer, yes, the interface facing the internal network, correct. So in this case that would be, if we do a, let's have a show IP int brief, without the fat fingers, we can see that it's fast Ethernet 01. Yeah, so that's our internal network. So we go FA0/1, and we go IP access group 110, and is it in or out? We've got a couple of different sponsors, so it's actually in. Yep. So what we want to do is we want to cut that traffic off before it gets to the routing process. So remember, if we go outbound, what that's saying is it has to come in through the interface for a start, go through the routing, and then send it out. But we don't want to do that. We want to just drop it cold on the interface, on the inbound interface of the router. So if you think of it, it's this interface. There's my highlighter. This interface right there. Okay, that's the way we're going to turn it off. So we're going to drop it straight from there. So we apply it to the inbound interface in the in direction. Now if we do show IP access list, we can see there it is, down the bottom here, and away we go. Okay, so that basically, that completes that side of the lab. Okay, so we've restricted access via, so we've got our access restricted to our management station. We've stopped our, we've done our IP address spoofing access list to stop spoofed addresses from coming in, and we've also said we only want this particular network to go out. Okay, so that's nice and straightforward. So the next one is, let me have a look at the router. Okay. This is yes. So the next router we want to move to is we want to move across to router 1. Now remember, one of the requirements is that we wanted this guy here. If we have a look at the IP address on this, so this is 1.3. So this server over here is running a number of services here. So he's running a web server, DHCP, TFTP, DNS, so on and so forth. He's running a number of different services over here. Now what we want to do is write an access list on router 1, so here, that only allows domain, so DNS, SMTP, FTP, and HTTPS from the PC on the other side. So this guy here, 3.1. Actually, that's incorrect. We don't want it. No, actually, we don't need to limit it to that particular host. But what we want to do is limit access to DNS, SMTP, FTP, HTTPS to this particular host. Okay, so we need to write an access list on this router that will do that. So this one's a little bit more. Complex. So have a think about what the answer to that may be, and then will show you. So we want to restrict, so using an extended access list 120, we want to restrict access from any source to the host 192.168.1.3 for DNS, SMTP, FTP, and HTTPS. Okay, so even if you just give me one of those, that's fine. We'll put it all together in a second. So I'll just get myself ready here. So I want you to write the actual ACL itself, and then I want you to tell me which interface you would put it on and which direction would it be. So it would be the serial interface, the fast Ethernet interface, would it be inbound or would it be outbound? Okay, so we've got some good answers coming in, which are all spot on. Yes, good, good. Okay, so it looks like through the answers that are coming in, you've got a pretty good grip on what's going on. So that's pretty good. So the answer is this. First part of the answer is this. Okay, access list 120, permit UDP from any to the host 192.168.1.3 equals domain, or you could equally put 53. Okay, some of you have put 53, and that's fine as well. Domain is actually a keyword inside the iOS that allows you to put that in, but you could put 53, that's fine. There's another one for SMTP. Again, you could put port 25. You could put 25 instead of SMTP. FTP, you could put 21 instead of FTP. Interestingly enough, you have to put in 443 because they don't have one for HTTPS or secure, well, at least not in this version of Packet Tracer. I believe in some of the later versions of ORS, yes they do, but not in this one. So that's the access list. That is the correct access list based on the requirements that I've just said. The next question is, where does it go? And so if we look at our diagram, we're talking about this router here. We have a serial interface here, which is 000, and we have the fast Ethernet interface over there. Okay, so I've already got a couple of answers which are correct. So we'll go to router 1. I said we'll go to router 1. There it is. Okay, so the answer is to the serial interface. Okay, and it's on the inbound direction. And the reason it's on the inbound direction is because we want to drop it before it gets to the part where it's actually doing any routing calculations. Okay, so we just want to drop it and get rid of it, and that's the end of it. Old mate traffic dies, and that's the end of it. Okay, so if we now go back and have a look at the running config, we can see a number of things that have happened. We've got our serial interface with our access group coming in. Now, something I haven't clarified, but I think there was a question about before, is IP access group is the keyword you use to apply it to an interface. Okay, access group to an interface. If it's a virtual terminal line, you use the keyword access class. That's exactly the same thing. It will do exactly the same job, but one is for interfaces and one is for the actual virtual, the VTY lines. Okay, then as we scroll down more, we can see access list 10. So that was the one that was stopping, remember, limiting our management access. Then we've got our access list, which was just limiting what we were just talking about then, the traffic that we were talking about then. Okay, and you can see down here on the line VTY04, access class 10 in. So again, access list 10, which is this one up here, and we're going to apply that in the inbound direction on the VTY lines. Okay. Now, just to backtrack a little bit from last week, there's a couple of things that I want to note here in terms of the security templates that we were talking about. So first of all, service password encryption. So basically what that does doesn't change. See this one here, this is the enable secret password. Doesn't change that, that's always MD5 hashed. But if you don't specify service password encryption, then this password here, actually this one would be because you've specified secret. But you could put, I'll give you an example. Let's go into here and we go no service password encryption, okay? And we go username Cisco, password Cisco. We'll show run. You can see that the username just goes in as Cisco. Of course the username does, because that's what it is. The password just goes in as Cisco in plain text, okay, so you can see it. Now you'll notice that this one here is still hashed, even though I've turned password encryption off. Two reasons for that. One is that it's using the secret keyword. Anytime you use a secret keyword, it will automatically MD5 hash. But secondly, if you've got password encryption turned on and you configure usernames and passwords, it will encrypt them. If you then turn it off, those passwords will not be reverse hashed. They will just stay in the same format. So say, for instance, now we can see that that password's in clear text. When we put on password encryption, let's have a look at the run again. You can see now it's been reversed. Okay, so it's now MD5 hashed. The Cisco. We know it says Cisco. We know that this entry is Cisco, but you can't read it now because it's been hashed. Now, watch what happens if I go no service password encryption. Okay, if we have a look at the run again, see it still doesn't matter. but I can put in another username, so username test, password test, do show run, so it's there. So it's worthwhile understanding that, turning off password encryption doesn't mean that your passwords will be reverse hashed. It just means that for anything new going into it, it won't be applied. Okay, so that's one point that just to confirm what we were talking about last week. I'll just pick out another couple before we finish up for the night, because I understand that we've probably gone a little bit over time, but that's all right. There's been plenty of questions, and that's been well and truly worthwhile. Okay, the other probably main one. These are pretty simple, but the other couple of main ones here are on the line console 0. We've got the exec timeout 00. That basically means in this case it never times out. So if you plug into your console port, it'll never time out, which isn't ideal. You'd really want to put a timeout value on that, so exec timeout 50 or something like that for 5 minutes. The other one that is reasonably obvious here is we've put an access list on our V2Y lines, we've got our service password encryption, we've got login local here, so that enables login processing for local accounts only, so there's no TACAX or radius or anything on this one. And in this case here, but this case here is another one, transport input SSH. So what we're saying there is transport coming into the router must be SSH. So in other words, if you want to connect to the VTY lines or the terminal lines, you have to use SSH. Okay, you can't use Telnet. If I tried to Telnet to that router, it would just reject me. It wouldn't be interested. You have to use SSH. Okay, you see here they've also not best practices. It's set at IPSSH version 1, but again that could be because Packet Tracer doesn't support that. We've turned off service timestamps for log and debug. Okay, normally you'd leave that on. You'd want to leave that on as a security template. So this is a good example of what not to do as a security template. But again, it's just a Packet Tracer lab, so it's it's just a basic template that you can use. Later on, probably in the last week, we'll have a look at another more advanced security lab which will take into account a lot of the features that we've been talking about. Now someone's just made a note, can we get an outbound example on an access list? The only thing I'll say is it simply looks like this. If I get the command right, IP access group 110 out. That's the only difference. Okay, it's just an application of the direction, and so it's no different to. It still uses the same IP address. It still uses the same IP access list. Nothing else changes, so it just becomes a direction in or out. The main thing to remember is that the inbound direction will block traffic before it goes through any route processing. The outbound direction will not. Okay. So if we're looking at, let's just close that down now because we don't need that anymore. We'll just close these windows here that we don't need. So if we're to look at router 2, for instance, and we're trying to block traffic from, let's use our highlight, let's use my highlight pen, just so I can illustrate this. So if we're trying to block traffic going this way at router 2, there's two ways we could do it, obviously. We could apply an inbound access list on that interface, or we could apply an outbound access list on that interface. Either one is valid and either one would work, but why would you do one over the other? The answer is if you apply an inbound access list here, if the traffic's coming from this direction, it'll be dropped there before it goes through route processing. Okay, if you do an outbound access list here, it would still work and do the same thing, but it just means that the router has to process it, okay, first, and process the routing and then send it, and then to go, oh, okay, I actually have to block that. So it's just a matter of which direction the traffic's coming through, where it's going, whether you're using standard or extended. It depends. That determines. So whether you're using standard or extended can, to a lesser degree, determine where you actually place the access list, and the direction of which the access list is placed on the interface is dependent on from which direction the traffic's coming and what you're trying to do with that. Okay, so if you're trying to block it, you would always try to block inbound, I shouldn't say always, most of the time you would try to block on the inbound direction before it went through that processor. Okay, so I hope that makes sense. That's right. Just another question. Type 7 hashing easily reversed. I wouldn't say easily reversed, but more easily reversed, yes. Absolutely. Absolutely, no doubt about that. So if you use secret hashing, then it's much more, it's a stronger algorithm, it's more difficult to reverse. But still, it can be reversed. Nothing is completely secure. Absolutely nothing is completely secure. And there are a number of, and as far as Type 7 is concerned, there are a number of online tools and free downloadable tools that you can get that will reverse that encryption, whereas the Type 5, that's not possible. It actually uses an MD5 hash that can't be easily reverse engineered with normal sort of tools anyway. All right, so that's pretty much it for this evening. Next week we're going to be talking about, I'll just go back to here. Now, just a note, I will put the couple of labs that I've been working on tonight, there's a couple of labs next week. I'm getting a week ahead of myself. I'll put the lab up tonight so that if you have access to Packet Tracer version 6 or above, you can use that and have a mess around with it and follow through as I've done. Next week we'll also be looking at a couple of labs, one that sort of builds a little bit on what we've learned this week with access lists, so that'll be doing what's called CBAC, so context-based access control. So I'll get you to have a bit of a read of that. I haven't put up anything on the Moodle portal for that just at the moment, but that'll probably come next week. And we'll also be doing a bit of a lab on configuring a zone-based policy firewall. Okay, now again, these are simple labs, they're simple packet tracer labs, but they are sufficient for the purpose of the CCNA security exam. So, summary for the exam, in terms of the exam, ACLs can be used for many purposes, you just need to know the basics. So the difference between the different ACL types. So have a look at the documentation that I've popped up. There's quite a bit of documentation on the different types of access lists that are available. I don't expect, you don't need to know a whole lot about them, but just understand the difference between them and the major differences between them. So, for instance, standard user source only, extended user source destination and layer 4 stuff. Reflexive access lists are used to generate dynamic rules based on certain established connections. You've got your lock and key or time-based ACLs. Okay, so know the general differences with those and how to protect against some common attacks. Okay, so again, there's some documentation up there that will allow you to step through that. And next week we'll build on that again as we talk about firewall technology and how that's applied in an iOS-based platform. So we're not going to be looking at, don't come next week, I think we'll be talking about ASAs. There might be a few snippets on ASAs in there, but we won't be doing any lab work on that. That will be basically, we'll be talking about how it relates to iOS devices only. Okay, readings on Moodle, already talked about that. Next week, firewall technology, same time, same place. Thank you very much for your patience. It's been a long one tonight. Next week will probably be a little bit shorter, although it may not, because we generated a lot of questions tonight, which was really, really good. That's going to help your learning. So feel free to ask questions during the session, and by all means put them up on Moodle as well, on the forums. So yeah. I hope you enjoyed tonight. I hope you got something out of it. As I said, next week we'll start at 7. We'll probably go through to around about 8:30. So yeah, see you same time next week. Enjoy the rest of your week. Bye guys.